Today's webinar's title is HART Technology for Industrial Wireless Sensor Networks. My name is Peng, and I have been working at CMC Microsystems for managing R&D projects in the area of industrial wireless sensor networks and embedded systems. And today I'm very excited to do this webinar with our guest speaker, Dr. Jeb Song from AwiaTech. Let's switch slides. So before we get started, I would like to give a brief introduction to Dr. Song. And Dr. Song is the Chief Technology Officer at AwiaTech. He obtained a PhD degree from University of Texas, Austin, and he recipient of ISA Excellence in Documentation Award 2007, and has extensive knowledge of WirelessHART technologies. And I'm very pleased to have today. The outline, I would like to give a brief introduction to CMC for those of you who don't know CMC very well, and followed by the brief overview of industrial wireless sensor networks. And the song will cover the essential knowledge of WirelessHART technologies for another around 40 minutes. And, I will continue to talk about the CMC support for industrial wireless sensor network related R&D, and we can then we give the conclusion and start the Q&A session. CMC Microsystems is a not-for-profit corporation founded in 1984 to support Canada's national design network. With over 30-year history, CMC Microsystems enables and supports the creation and application of micro and nano system knowledge by providing national infrastructure for excellence in research and establishing a path to commercialization of related devices, components, and systems. Speaking of Canada's National Design Network, it consists of 54 universities and colleges and hundreds of faculties and research staff as postgraduate students and in the connected companies. We have been generating a very great impact through the past 30 years in highly qualified personnel education and their publication and related research, as well as commercialization. I want to talk about our CMC's joint R&D program is called the CMC Solutions. This program will defray costs for embedded systems and microsystems development and prototyping, and contribute HR resources for collaborative R&D projects that are structured for mutual benefit to clients and to the NDN. It directly contributes to clients' R&D objectives and adds to the set of technologies, services, or capabilities delivered to the National Design Network. So please feel free to check more details on our website. So I would like to start with the brief overview of industrial wireless sensor networks. So industrial wireless sensor network has great potential for a lot of applications in industry and commercial areas. And it's reported that industrial wireless sensor networks are projected to increase by 553% in the next 5 years to nearly 24 million installed sensor points. So, we may have heard a lot of this buzzword in the recent years, but we really have to focus on the definition of it. So I adopted definition from the book published in 2013, last year. The industrial wireless sensor networks are an emerging class of wireless sensor networks for industrial production. So with this definition, it has different characteristics included. In example, the easy deployment and installation of the the network, and scalable, suitable for hash development. To use low power consumption of devices as the automated operations. So there are several mainstream applications of industrial wireless sensor networks, and that contributes to the popularity of this type of network. For example, environmental sensing for pollution, hazard, and security, as well as condition monitoring for the building structure monitoring, condition monitoring for electromotors, for example, as well as process automation to improve the evaluation and the management process of the process automation line, as well as asset management, for example, to track the devices and to add information transparency to the resource asset management of the company. The network for industrial applications has different settings in terms of network topologies, such as star network and mesh network, that can suit for different needs of industrial applications. And quite a few innovation areas, including communications, how to reduce the costs of devices and the system, and how to improve the power efficiency, and how to employ the harvesting, as well as the sensing fabrication brought by the MEMS technology or NAMS technology, as well as the data intelligence for operations and management. So it also comes with the research challenges we have to deal with. For example, the number one issue from the survey done recently says the data reliability is the concern, followed by the data security, timeless operation lifetime, and so on. So if you look at the graph I show here, which is from a paper published 2 years ago, showing the 2.5 gigahertz band AO2.15.4 channels, their receive the signal strength indicator, how there varies over time from channel to channel. So we can see that the channel, for each channel, the wireless signal is not stable as we thought. So to deal with these challenges, most protocols, wireless communication protocols, and networking protocols are trying to solve this problem. On those protocols, we have listed several of them as the prioritized ones because from the recent survey of the potential users. Those technologies include WirelessHART, ISA 100.11a, and other IEEE AO2.15.4 based ones. WirelessHART and ISA 100.11a are based on AO2.15.4 technology. So that's my review for wireless sensor networks, and I would like to move to Dr. Jeff Sum's presentation for the WirelessHART technology.
Guys, Jeff Sung, it's a great honor for me and AwiaTech to give this talk in this webinar. And thank you, Peng, for one introduction. This is an outline for my talk. So first, I will give an overview of the HART, the deck, and the protocol, and then I will list a list of features for HART, some interesting research topics related to WirelessHART. A brief overview of the WirelessHART platform from our company AwiaTech. I will do two demos to demonstrate reliability of WirelessHART platform. As convention is WirelessHART is just one industry process standard for highway adjustable remote transducer. It is to this national standard in 2007. Right now, it is a market share of more than 85%. It is a de facto industry standard in process control. HART first comes out as part of this HART 7 specification. It is intended to complement traditional HART to replace what does best. WirelessHART focuses on smart process control field devices. Of features of WirelessHART. HART is based on the HART low power, low range radio. On top of that, it defines its own TDMA-based communicators. That's the macro layer. They also WirelessHART also supports channel hopping. Reduce the network bandwidth because then a different device can talk in channels, and then is more resilient to external interference. To add more reliability, what also support mesh networking network layer. I think from the list of features, what requires a centralized network to schedule and manage the whole network. Typical WirelessHART network. In the network, a bunch of field devices. So one handheld showing this picture. Field devices talk to the gateways. The central network manager manages to redact gates. In HART networks, the devices talk WirelessHART protocol. From the way to network manager or to the host application, it just uses the standard TCP/IP protocol. Some very interesting wireless-related research topics. This one is scheduling in WirelessHART networks. Come up with different scheduling algorithms based on the optimization gates. For example, in a process control network loop, you reduce the response time from the actuator and come up with a set or summarization for this target. If we want to reduce the loss, increase the reliability of the network, there may be some other optimal scheduling algorithm. Or power efficiency is most of the WirelessHART devices are of battery, and it's also an interesting target if we want to increase the lifetime of the whole network. The power efficiency means the power efficiency of the whole network, not individual devices. The interesting topic is localization. A typical WirelessHART network deployment, the network operator, they need to know the location of the worker in a plant, because the plant may have some hazard area they need to be aware of the location of the worker. So the worker will carry a handheld and two hard devices nearby. Some preliminary research on the topic. Those are some anchor nodes and use the triangulation and RSSI to locate the location of the handheld. So use this method, we achieve about this accuracy, but it can be further improved. Already some papers published on this topic. Then to incorporate all these industry wireless sensor network into the internet. Did some research work on this. We implement 6-LoWPAN on top of HART, so that from the internet, we can use browser to access each individual wireless device in HART network. Some other industry sensor network, for example, the ISO 100. There's IETF task group to run IP protocol on top of this TDMA-based MAC, 60. So if you guys are interested in this topic, maybe you should check it out. Here, a brief background of AwiaTech. For advancing wireless industry automation, it is built on more than 6 years academic research in the University of Texas at Austin. As you can see, I graduated from this university, so I did some research on WirelessHART, my PhD studies. So AwiaTech was incorporated in 2008 to commercialize WirelessHART software. We focus on WirelessHART only. This product comes we provide. This Awia command is just a network manager. In the middle, that's Awia Vanguard is a gateway. For this, we have Awia Warrior. That's WirelessHART runs on WirelessHART stack. It's built into the sensor to be a field device. We attended different experiences. Lecture that's in 2012. I will do 2 demos to demo WirelessHART platform. I want to demo is the system. Basically, we want to simulate the actual wireless network using a software. Then this way we can experiment different scaling algorithms in network. I want to do that software. This is the interface for this simulator. We can open networks. Different means the different number of nodes in network. For example, let's first open a simple one, 25 nodes. Is a network manager. To the blue nodes are filters. On the right panel, you can see we can define the period for different devices. Most of the nodes in network are sensors, so they send data to the gateway and network manager. They use uplink graph. So we can generate uplink graph. If it wants to change the configuration of the whole network, it uses the broadcast. It's a broadcast for how the message will from the transmit from the to each nodes. And you can also generate the schedule for the whole network based on the scanning period. So X is the time loss. While the channel, the Y-axis is the channel. Different means different type of slots. Slot is 10 milliseconds in WirelessHART network. This is global schedule. We can also take a look at individual device schedule. This is device ID according to this column, the ID column, and this is a time slot. Also, device means different. We get utilization of the nodes. Still definition so that in the end, if we have this simulation result, we export to real-world network manager so that it can deploy same configuration to configure the wireless network. We go over another network nodes. Or you can check the uplink graph, broadcast, and the schedule. This is much more complicated. Different utilization. Yes, we come from the research area, so we are interested in this simulation so that we can implement different algorithm and routing algorithm in the network. Go back to the simulator. We want to speed up the control loop, basically from the sensor to the actuator. So we put the idea that we build a control logic in the gateway. Additionally, we use a DCS to connect the sensors and the actuator. So the prototype we built. This is a YouTube video, so I will just play this video.
This is a demonstration of control in the gateway model. Network and gateway. We're running a host application which is to control and monitor the status of our setup. I have a packet sniffer running to observe the wireless network traffic. Stop is connected by USB to an access point and a packet sniffer. This is running a visualization of the network topology. It remotely connects to the network manager and displays information from the network manager. And for a closer look, we see the packet sniffer on the right side, which is currently showing the advertisements broadcasted from the access point. The left side shows the host application. No devices have joined yet, so the host is empty. And this is our network topology. The red represents the gateway, and the yellow represents the access point. Once devices start joining, they will be as dots. Our first device is approximately 10 feet away. The data traffic as the first device joins the network. The device now shows up in the network manager. Set up two devices and have them in the network. They are approximately 10 feet away in the opposite direction. The second device is set up much farther away. The actuator is also set up far away in the opposite direction. This is a close-up of the sensor device. We set an event by pressing this button, which will toggle an LED light and change the data being sent. When the light is on, the sensor is bursting a value of 1 to the gateway. When it's off, the sensor is bursting a value of 0. The actuator device looks just like this one, but in the value, the actuator will turn on its LED light and receive a value of 0, it will light off. This is the final topology of the network. The sensor on the bottom left, the actuator is on the bottom right. Now we use activate control logic in the gateway so that the gateway will begin sending commands to the actuator. The sensor is currently bursting a value of 1. Now window to show 3 separate devices. When the sensor is turned off, the sensor will burst 0 to the gateway, which will tell the actuator to turn off its LED light.
Let's talk. Sorry, guys. Not familiar with this WebEx. So just now, maybe I'm still showing the similar, not showing this demo. Because for this talk, I didn't to give you guys a brief introduction for different topics. So if you guys are interested in some specific we can go back and have a discussion.
Okay, thanks very much for Dr. Zhong's presentation about WirelessHART technologies. So some of you who didn't see the video in the first beginning of the demo, we can follow up by sending the video link email later on. So for now, I would like to talk about the CMC support for interoperable wireless sensor network related R&D, including the testbed we have been building right now. So we'd like to start with a couple of CMC solutions projects. First one is WirelessHART-based testbed for interoperable wireless sensor networks. So we're doing this with Western University, Canada, with the Jin Jiang's team. And this project intends to develop the IWSN testbed for and deploy on the new process control test facility at certain can simulate the interoperable control process and support various research areas, including the advanced control, fault diagnostics, sensors, smart sensors, and passive safety. So we're gonna deliver to the Canadian research community with an industry wireless network-based WirelessHART platform, and gonna provide some documentation on how to do this and what's technology involved, and as well as a case study result. Also, we're open to have the training course opportunities and workshop opportunities later. So, technical side of project includes four key components. The first one is the WirelessHART network. So I'm going to show those components really on this figure. So WirelessHART, we have been deployed, the initial deployment, the facility, process control test facility, Western and Dr. Jin Zhang's lab. Those are the field devices right on the facility, and I think there's a gateway just behind of this computer. We can see, and there are a bunch of field devices distributed on the table. So, so the first part, we have to make the WirelessHART network correctly deployed on the target. And the second component is the WirelessHART system integration in this distributed control system. The distributed control system connects the actuators and sensors of the facility shown on the background. And we have to ensure sensor and actuator interface and calibration work correctly, as well as we have to do the modification of the WirelessHART node firmware, which will based on the WirelessHART, the software development kit. Also, the distributed control system integration. And so in this way, and the system can be controlled, switch to be controlled by the DCS system and WirelessHART. And the third component is the WirelessHART network operations with the OPC server and the HART IP protocols. So the OPC server is actually the software suite running on the computer with the Emerson DCS system control the sensors and actuators, and it has to talk with the WirelessHART gateway, following the HART IP protocols or some UDP protocols. But HART IP is a certified one, so it's good to have this communication happen. It includes OPC, so it has a host workstation running the OPC human-machine interface application, and has to do the protocol conversion. For example, the HART IP protocol gateway and the OPC protocol can talk. They can do the version on the computer with the software, and as well as gateway communication. And the gateway communication is done by the Wi-Fi router. So the computer connects to the Wi-Fi router, and they can talk together with a typical work following the UDP sessions. And then the last part is the wireless access really accessible model, because this part is for the research purposes, but it's also open for the other application, industrial applications. It has the middleware that's running on the workstation in the field. It has web applications running on remote server or the server in the field as well. So support secure access and flexible probability and real-time data connectivity based on the latest WebSocket protocol or other Internet of Things constrained application protocol. So I'm going to show you this is the enlarged picture of the field devices deployed on the facility, and this is the example of the remote access module we developed to monitor the sensors, which is remotely employed on the facility web application. And so to summarize, how can we do with WirelessHART Testbed? basically, it includes different components. The first components, as we know, is the WirelessHART network. So we can do the communication and networking experiments in this. And we can do some physical layer to network layer experimentation with the WirelessHART compliant software-defined kit. It can also, we can use the record industrial noise for the with the real-world industrial environment. So, I think this work has been done by the Jin Jiang's team at West University. As well, also we can do some case studies for nuclear power plants or general process control applications and their monitoring applications with wireless networks, as well as the standardization research activities regarding industrial wireless sensor networks. As this standardization is an evolving area, it's like the WirelessHART ISA 100 or other open like IEEE, ITF standards. They're waiting for research inputs so we can have good results contribute to this community, and can support other general process automation research-related topics, and also the big data analytics and the industrial cloud services. Because if we deploy the web application and the middleware into the testbed system, this is something we can do in a larger scale. Another CMC Solutions project is entitled Self-Powered Sensor Network Testbed for Machine Condition Monitoring. So this is not a WirelessHART based, but it's related. Basically, it's using a 6LoWPAN client platform for the wireless sensor networks. So we studied the distributed testbed platform for industrial machine condition monitoring with the accurate machine condition parameters transmitted to the remote server in the field. And this, we are using the IP-based architecture for this industrial wireless sensor network. Developed a prototype to show effectiveness of the proposed IP-based solution. So there are several deliverables. The first one is the 6LoWPAN and ZigBee compliant open platform for the community, and the second would be the testbed itself that can up and running and remotely accessible for its data. So to make sure the data visualization is possible, and, which is also extensible for other monitoring purposes or industrial application specific purposes. We will also provide application notes on the circuit design, power management design, and testbed usage as the sensor cloud web application and the data connected tool, just to different pieces together as a whole system in the area of industrial wireless sensor networks, also the area of Internet of Things. So the a detailed picture of the system architecture shown on the right. So different components, but the three major components we're talking about is the wireless sensor node supporting 6LoWPAN protocol and CAP protocol, as well as the edge router that can directly to the sensor nodes, as well as the node servers. So in this way, edge router is an important role supporting two-way communications between sensor nodes and the remote servers. And the end-to-end connectivity of network of those three essential network entities is shown here. So that's for the project have been supported, collaborative R&D projects we have been supported. And we also support the wireless sensor network platforms of the MCScan project deliverables. The MCScan stands for Embedded System Canada. Is a 5-year project starting a couple of years ago, and we're just in the mid through the completion of this project. So we still follow the level of the platform itself. Still follows IP-based connectivity, consisting of 3 essential components, including the remote cloud services, gateway, and the local wireless sensor network testbed, consisting of small sensors or heterogeneous sensors for industrial applications and for other applications. And also, we have been supported the embedded systems in studying the research topics of industrial wireless networks or server networks, because we have for some functions we have to understand how to accelerate the algorithm and how can we support the software-defined radios to improve the wireless communication between the sensor nodes, and how we improve the cloud services using the development systems that have been installed across Canadian University. We can do those research topics surrounding the IWSN, as well as the CAD design tools. We've been supporting the, for example, the real-time software verification and design tools, as well as the added software design tools such as ARM DS5 for the ARM high-end microprocessor research. And also have supported different services such as training and workshops and flows and methodology training courses, webinars, and we have community space so you can check out and ask questions about those embedded systems. So all those technologies will be used to support the various R&D activities, which is projected to have a larger impact on the various research results and innovations for Canadian research community through the support of CMC-enabled technology and R&D projects. We all have a view of the next generations of developed systems in covering the following areas, including the big data, cybersecurity, Internet of Things, as well as the low-level micro technology fabrication for the sensors and or other energy harvesting modules, for example. So we have a brief conclusion. So WirelessHART is a very promising technology to enable the inter-wireless sensor network R&D activities, and the research activities surrounding it can be supported by our current and future offerings and the collaborative R&D projects. So, at this point, I would like very much to know your feedback. Let us improve our support and deliverables in this very emerging field. So my presentation. Thanks very much.
The call has been muted. Has been unmuted.
Start with the Q&A session. If you have questions, feel free to ask.
Hello.
Yes.
I have a question regarding the simulators you have shown.
Okay.
Are we able to change the channel models in those simulators, or I mean, essentially the physical layer, modulation schemes and all stuff? Can we check that?
That you want to change the modulation method.
Or the link layers, for example, when the gateway talks to the sensors, for example, which channel model have been used, free space or multi-path, whatever. So there's some Yeah.
So right now we still focus on the idea.
Okay. Okay. Yeah. So do not simulate like the impact of a wireless environment, like when you have like mud fading or so forth. So that's not
level yet.
okay.
That's a good point, right?
Yeah, but let's say if you mentioned that but that's just for the simulator. So you mentioned that you have used this for localizations, like using the RSI, for example.
Right.
So simulator, if you want to simulate these scenarios, would we be able to do that, or?
Interesting question. So we for the simulator, as I made in a talk, so we focus on two different topology and different scheduling and routing algorithms.
Okay.
Namely, for that, slightly different because for the localization, we also use machine learning in the net manager side to location of the basic location of the handhold.
Okay. Okay. So experiment now. Would we be able to change the modulation scheme, or do we have this capacity to change the modulation scheme on the or the gateway or the network manager whatsoever?
I'm not sure you can do this. You mean for the real hardware, right?
Yes, yeah, for the real hardware. Yeah.
For the real hardware, we use the TI radio, SIG radio.
GNU radio, you mean?
TI CC 2520.
Oh, okay. Okay.
You can
if you want, I mean, to improve the system, for example, at the physical layer, let's say you have some algorithms. So and these algorithms require that you change, that you choose like a specific modulation scheme, or, for example, to some adaptive algorithm to improve the channel. So how can we do that with this nodes? Is it done at the network manager level, or like the integration of software-defined radio, for example, how it is done? For example, if there is an HDR platform, it is connected to this network.
Right. So yeah, just now you mentioned a software-defined radio. We once have this but unfortunately for this exact hardware, the software we don't support that yet.
Okay. So platform, what does it include for now? The platform that you are proposing for C.
So the way with the network manager running on top of that.
So how many gateways? It includes 2 gateways?
No, it
just gateway. Okay, and the network manager?
Yes, the network manager.
Any nodes?
That depends. So you can voice of 20 nodes.
So the platform, for example, will come with 1 gateway, network manager plus 20 nodes. Anything else, or?
So as we talk to CMC, we can also have this open source stack. You can modify as soon as you want to do some customization on this layer.
Okay, that's perfect. Yeah.
Provide license to access to the open source WirelessHART stack.
Oh, perfect. Okay, so yeah, and it is compatible with ZigBee and other wireless standards. Is it?
The ZigBee is exactly the ZigBee, but on top of from the MAC layer, that's different thing.
Oh, okay, so it's very similar.
Yeah, but right now there's no thing called WirelessHART radio. They use ZigBee radio.
Oh, perfect. Oh, for the notes, perfect. Okay. Thank you very much. So we'll keep in touch and see what we can do.
Okay. Yeah, let me know if you have more questions.
Thank you very much. Yeah.
Okay.
I have questions. Hello?
Mm-hmm.
Yeah.
Uh-huh.
Good question. I guess when you make the presentation of those graphs and things like that, I didn't see what kind of latency or delay that you have between the sensor reading and actuation.
Yes, because that totally depends on the network schedule. That's decided by the network manager.
I mean, what is the shortest? I mean, delay that have you experienced?
About 500 milliseconds.
Okay, 5 milliseconds. When you we purchased one of your SDK from AwiaTech, your company.
Mm-hmm.
And have you released any new version of software yet? I mean,
we are keeping updating the software. We have some updates.
Okay, how can we update the newer versions?
Maybe we can talk this offline. So can you send email? So so are you talking me?
Yeah, I'm Kang Lee from NIST. Yes.
Oh, so we talked we sent you emails before, right? So
I'll send you email.
Yes, yeah, we are happy to upgrade your the evaluation kit.
Yeah. There's another question that I have since we're on the phone here.
Mm-hmm.
If I want to connect your sensor output to a simulator through cable, is the output impedance of your antenna, can it support 50 ohm?
The antenna for our sensor.
Yeah, right. I mean, okay, we want to we're building a simulator that in the RF signal, not by radio but through cable, and want to maybe connect your radio to the simulator directly via RF cable. Is that?
Okay.
But the impedance is 50 ohm. Do you think that there's any problem?
I may double check with our hardware engineer.
Okay. All right.
Yeah, I'll get back to you.
Okay. All right. Yeah. Okay. Very good. You picked the day here. It's pretty. Not many people can attend this. Some of our people later, but
right.
Yeah, I don't know if you are aware of that or not when you organize it.
Maybe you can answer this question.
Yeah, this system, so we did do it in November, and so we try to avoid the beta date December. So I think that's the thing. We can have a second webinar if you think most people were interested in.
Oh, so, by the way, okay. Yeah, it doesn't matter. Do you have a recording of this that you can share with some other people who couldn't attend?
Yeah, we recorded the webinar. And,
okay.
Yeah.
Yeah, you can maybe somehow have an email send it to us and location where we can someone can.
Yeah.
Okay. All right. Very nice. Thank you very much.
Thank
Have a
you.
nice Thanksgiving. I'll send you an email on some of the questions I have.
Okay. Okay. Thank you.
Bye-bye.
Bye.
Other questions?
Yeah, this is Ramiro speaking.
Oh, sure. How are
How you
you?
doing, Peng? I don't think I've met Jeff. A question maybe to you, Peng, that and a little bit to Jeff as well is a project that we're going to be trying to build or adapt a sensor for WirelessHART. So hence, we need to design the software plus really integrate the actual physical sensor into a WirelessHART platform. I've been looking at the Dust Networks, I never heard why, but Dust Networks platforms. I don't know, can C also help in your test bed if one needs to take a sensor and integrate it into a WirelessHART system?
It's definitely interesting. So I think we can talk about it offline for the project. Yeah. Yeah.
Okay.
So if you have any technical questions about the WirelessHART technologies, I think it's a good chance to ask Dr. Sung since he's here. We can do.
I had questions related to simulator that are going. It wasn't clear in my mind that simulator you have, is that like an open source simulator that one can in the research community?
Yeah, very good question. So right now, because we haven't completed yet, and eventually we want to release to the research community, but right now, not ready yet.
All right.
Yeah. Just you asked about connect a sensor to our module. Yeah, let's one of our features. So as you can see from Peng's slides, also we already connect some sensors to in UWO with this project. So we connect some sensors to our wireless module.
Looking at your documentation for your kit, but I'll look more at it to see whether, because we need to connect a digital, we need to actually, we don't have a HART sensor, so I need to actually build a microprocessor and radio communication and everything like that to make it WirelessHART compatible. So it's like we're building it from scratch.
Great. Any other questions from the audience? Question for another couple of minutes. So, thanks for everyone attending this webinar. So we will follow up by sending an email to all of you this webinar. And thanks very much.
Thank you very much, Dr. Jeff and Peng. Thank you very much.
Thank you.
Thank you, guys.
Yeah. Peng, do you have your phone number there, please, so I can call you?
Sure. Yeah.
I'm Mustafa from RMC. I'm just close to you.
Oh, yeah, that's great. I'll get an email. I think I can follow up by sending you an email later on.
Oh, perfect. So yeah. Well, then you can send me an email and give me your phone number.
Right.
So
yeah.
Perfect. Yeah.
Great.
Yeah. Okay. Okay. Very much.
Thank you.
Bye. Bye.
Bye.